Hello, this is section 5.2 inverse functions and their representations. So inverse function, in general, if the f of a equal to b and then inverse of the b equal to a, that is f output b with the input a, then the inverse must be output of with the input b. So they are switching around. So if this is actually the input for the f function to get output for b, then now b becomes the input for the inverse function to get output for the a. That's what we call the input and output. So composition with the inverse function is if you composite the function with the inverse, and then output is always come out as x. And determine that if the function has an inverse, if the different input of the function f produce the same output, then the inverse function of the f does not exist. However, if the different input always produce a different output, we call the function is one-to-one function, which is that has always inverse functions. So determine that the function represent the table has the inverse function, so which is different input. So different input actually different input to get the different output, but otherwise actually the two inputs get the same output, right? So because this case it's not this function, the function does not have inverse because of the 2n69 and the 4n69. Alrighty, so one-to-one function. So when you have a one-to-one function, which is all elements C and D in the domain F, and the C is not same as a D, implies the F of C is not same as F of D. So different input always result in different outputs. So horizontal line test, which is horizontal line is this is horizontal line, okay? So if you put the bunch of the horizontal line on the graph, and then the horizontal line must be intersect the function only the once at the most. And then increasing, decreasing, and one-to-one functions. So if the continuous function f is always increasing on domain, then the every horizontal the line will intersect the graph f at most once, and by the horizontal line test of f is a one-to-one function. Similarly, if continuous function g is only decreasing on the domain, and then g is a one-to-one function too. So example 2, use a graph. The function is 1-to-1. So as a 1-to-1 function, since we have a graph, just put the horizontal line. So as you notice that the horizontal line has a 3 intersect here, right? That means so this function is not a 1-to-1. That means it doesn't have inverse functions, okay? But if you put the horizontal line here, everywhere, anywhere you want, okay? Do you see the only one intersect from the and each of the horizontal? So this is a one-to-one function. Okay, all right, next page, inverse function. So if the function be a one-to-one function and the inverse is this notation for inverse is the inverse function of f if the composition come out as x. So finding a symbolic representations for inverse functions. So step 1, verify the f is a 1-to-1. And then the solve the equation is f of x for x. Obtain the equation as a inverse form and the interchange of x and y. And then you need to check that out as composition come out as an x by itself. So numerical representation of the inverse on the top table. F computes the percentage of the U.S. populations with the 4 or more years, and then of the college in X. And then the bottom table shows a numerical representation as switch around here. So if you switch around, and that becomes the inverse functions here. So and then domain and then range are the interchange of the inverse function too. So when you get the domain as those are number as we call the this is a function, and then now the going to the other direction. So this is now domain and range as we call inverse. And then 1 goes 4, 2 goes 4, 3 goes 5. So this is actually the function because different axis goes has only one the output. But otherwise, now 4 becomes the corresponding to the 2 value in the range as a domain. So that's not going to be actually the inverse, okay? So there's no inverse for that kind of stuff. And then what happened for the graph is the graph of the function, their inverses are always symmetric with respect to the y equal to x line, as you notice here, right? So if this is actually the functions, and then always go out to the inverse, okay? So point is, this is 0, 1, you get the 1, 0. 1, 2, you got 2, 1. About here, but that's it's better. 2, 5, and you got 5 or 2, okay? And then when you plot them, and then you get the graph of the inverse. Alright, so number 3. So in the number 3, f be a one-to-one function given by the f of x is a cube root of x minus 2. So find the formula for the inverse function. So f of x equal to the cube root of x minus 2. So which is you got to use a y. Still cube root of x minus 2. And then so for x, which is you gotta cube both sides to cancel the cube root. So y cube is x minus 2, and then so for x plus 2, and you got y cube plus 2 equal to the x, and then now interchange of x and y, so it's going to be x cubed plus 2 equal to y, and then which is y is equal to x cubed plus 2, but now this is the inverse, so you need to change the inverse notation, which is x cubed plus 2. So that's all. Identify the domain and the range of the inverse. Okay, so inverse function domain, so I'm talking about this, okay? Domain is all real number because it's a cube root function. The range is also the all real number too. And the verify which of the part A is correct, which is if you use the composition with the function and inverse, and the outcome should be the x. So I'll put it the function with the inverse first, okay? So function was cube root of x. X is the inverse of x. And subtract 2. Now inverse is now x cubed plus 2 minus 2. Cancel. Cube root of x cubed is x. That's what I'm expecting. Other way, inverse composed with the function f. So inverse of f of x. So inverse is x cubed plus 2. The x, you plug it in f of x. The f of x function is cube root of x minus 2 cubed. And then cube and cube root cancel. So x minus 2 plus 2 cancel. You got the x's. So yeah, they are the inverse function. Now, example 4. Circumference of circle with the radius x is given by f of x equal to pi x. Explain the why f is a one-to-one function because it's from the variable, which is the x, isn't it? That's a linear. Okay, degree of 1 means a linear. So f is linear. So all the linear function is because it's a linear function, so which is a one-to-one. Okay, and then find the formula for the inverse. Okay, so you got that as f of x equal to 2 pi x, y equal to 2 pi x, and so for x, so y over 2 pi, and the interchange, okay, so x over 2 pi or equal to y. Now this is the inverse. And then we gotta find the inverse notation too, right? Okay, so x over 2 pi. All right, verify that this is the inverse function of f. So yeah. So f composes the inverse of x. So f function is 2 pi x. X the inverse was x over 2 pi, which is cancel. X comes out. The directions also need to check that out too. So inverse of f of x, which is Inverse was x over, so f of x over 2 pi. F of x is about 2 pi x over 2 pi. 2 pi cancel, so you got the x comes out too. Now, you need to plug it in 60 into the inverse function. So x is a 60 over 2 pi, which is going to be a 30 over pi, which is a 9.55. So if you want to, so this is actually the 60 is going to be the circumference, and then the radius. This is now the radius. Radius come out as 9.55 if this is the circumference. Okay, because function is plugged in the radius to find out the circumference, but the inverse function is plugged into the circumference to figure out the radius. Alright, next page. F of x equal to x plus 2 squared. Does the f is inverse functions? Okay, so let's grab this. Okay, so on this time, actually, I'm going to start with the negative 2 becomes 0. And then actually negative 1 is a 1 and 3 is a 1. 0 is actually 4. So you got this graph, this parabola. But is it an inverse? Which is, we need to check for the one-to-one function, right? So when you put it in here, nope, there's a two intersection. So nope, f is not one-to-one. Now, B, restrict the domain of the f so that the inverse exists, okay? So which means you can choose it either way though, but for me, I'm only going to use x is greater or equal to negative 2. So I want to start from the negative 2 and then greater. So I only going to use this graph instead, which means since we restrict the domain, and then now the f is one-to-one now. Why? It passed the horizontal line test, which is about only intersection on here. Now, find the inverse of x for the restricted domain. So, your f of x was x plus 2 squared, and then y equal to x plus 2 squared, and then, so for x, which is square root on, okay, which is a plus minus. So, but we are solving for x right now, right? So either way, it's plus minus here. So plus minus radical y equal to the x plus 2 comes out. But we are only use x as a positive, so I only take the square of y as a positive, x plus 2. And then the interchange of x and y, square x equal to y plus 2. And subtract 2 both sides. Radical x minus 2, which is a y. So y is a radical x minus 2. And inverse notation, I got the x minus 2 here. Which means this time, the domain is x must be positive only, okay? If you put the negative, it becomes a imaginary number. Okay, so example 6. Your function is 2x minus 1. Sketch that as inverse. And then put here. So I want to sketch the 2x minus 1 first. Okay, so y-f is negative 1, and slope is 2 over 1. So 1, 2, 1, 1, 2, 1. Okay, so this is a graph that you can get. Okay, so this is our function. But inverse is easy to grab because you just need to put the order pair in the interchange. So 0, negative 1, negative 1, 0. 1, 1, still 1. 2, 3, 3, 2. And then if you connect this, you get this. So this is the inverse. And then what happened for this one inverse? When you have an inverse, there's a symmetric line, which is y equal to x, which is x and y come out the same. 1, 1, negative 1, 1, negative 2, 2, negative 2 right there. Okay, so this is y equal to x. Now use a graph to evaluate each of the expressions. So f of 2 only, right? Just the input, find the output. So f function 2 is going to be negative 3. Right? And then inverse. So now, this negative 3 is actually the y. So y is a negative 3. So y is a negative 3 where? Right here, right? So negative 1, 2, right here. And then your x is actually the what? 2, so equal to 2. Now, this is a y, right? But this is x, and this is a y, and this is now x, okay? Alright, so when you have a y is equal to 1, which is right here, actually, right, is 1, and the x is actually the 0, right? So it's a 0. So this is x right now. So your order pairs actually from the graph is 2 and negative 3, 2 and negative 3, and you got 0 and 1, which is that's actually the graph of functions. Alright, I think that's okay. So thank you for listening.